لا إله إلا الله محمد رسول الله.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين وصلى الله وسلم على سيدنا محمد وعلى آله وصحبه أجمعين. In the second episode of this series of presentations on why Islam is true, I gave evidence for the claim that God exists. In the next three presentations, I reiterated this evidence and examined the evidence that is advanced by those who disagree with the claim. And I showed that the claim that God does exist is based on evidence, but the objections against it are not based on any evidence at all, and that they are in fact all fallacious and flawed arguments. I'd like you to recall from the second presentation that the evidence for God's existence in my presentations is taken from the Quran. I pointed you to about 20 verses that you could reference for yourselves and focused on the first verse in the Quran to cite this argument as evidence for God's existence. And that is the 164th verse of the second chapter. This verse points to a variety of phenomena in the universe as evidence or signs for God's existence. It points to the creation of the heavens and the earth, to the succession of the night and day, to the ships that sail the sea, to the rain that falls from the sky, to the plants that grow out of the earth following that rain, to the multitude of animals, to the change of the winds and the clouds, all of these things as great and numerous signs for the existence of God. What verses like this verse are saying is that the universe is evidence for God's existence. In the second presentation, I posed the question, why is the universe evidence for God's existence? And I then gave you the first reason why the universe is evidence for God's existence. That reason is that the universe is contingent. In this presentation, I will give you a second reason why verses such as this one cite the universe as evidence for God's existence. That second reason is that the universe began to exist. This second reason is actually mentioned right at the beginning of this verse, when it says that the creation of the heavens and the earth is one of the great signs for the existence of God. In the second presentation, I focused on the contingency of the universe as evidence for God's existence, and I promised that I would return at a later time to explain that the creation of the universe is another piece of evidence for God's existence. That time has now come. The focus of this presentation is the fact that the universe began to exist. Let's step back for a moment to recap why the universe, or to be more precise, the existence of the universe, is evidence for God's existence. The first reason is that the existence of the universe is contingent. If we take the universe as a whole, then we would say that the fact that the existence of the universe is contingent means that it exists, but that it could have not existed. That being the case, there must be something other than the universe that made it exist, and that leads us to ask the following question: what is that thing that made it exist rather than not exist? Using the line of reasoning that I have explained in detail in the last four presentations, we can quickly conclude that the thing that made it exist must be a necessary being, and that necessary being is what we are referring to as God. This argument for God's existence is called the argument for God's existence from contingency. As a side note, when I call this argument the argument from contingency, I am translating the Arabic terminology of the Muslim theologians who formalized this argument over 1,000 years ago and called it in Arabic Dalilul Imkan. I am not referring to the argument from contingency in the Western philosophical tradition, which has the same name but which is different in a number of important ways from the argument in the Muslim theological tradition. I will, God willing, explain these differences in a later presentation. The second reason why the universe is evidence for God's existence is that it began to exist. If the universe began to exist, or in other words, if it did not exist and then began to exist, this also leads us to ask the question, then what made it exist? But this question is slightly different than the question that I just asked a little while ago. Before, when I asked the question, then what made it exist? I was asking it because the contingency of the universe's existence demands that if it exists, something must have made it exist. Here, when I ask the same question, I'm asking it because the creation of the universe demands that something must have made it exist. I will explain this difference in greater detail again, God willing, in a future presentation. For now, just make mental note that the two questions are in fact different, and that the two arguments are also quite different. This second argument is called the argument for God's existence from creation, which is a rough translation of its Arabic name in the terminology of the Muslim theologians, Dalilul Huduth. I will also explain in a later presentation that the contingency of the universe's existence entails that it began to exist, and that the fact that it began to exist entails its contingency. The two arguments are closely interrelated. But although they are interrelated, the second argument that I am about to explain in this presentation is more compelling than the one that I have explained in previous presentations. And even the most skeptical and critical of skeptics, if he is honest with himself, will see with the utmost ease from this argument that God absolutely must exist. Why is that so? I'll explain that shortly. But first, I want to show you that the universe did, in fact, without any doubt, begin to exist. As I explained in my first presentation, my approach throughout this series of presentations will be to take statements related to the truth of Islam as claims, and then examine the evidence for those claims as well as the evidence against them. Here, the claim that I am examining is the title of this presentation. The universe began to exist. What is the evidence that this claim is true? There are two kinds of evidence for the truth of this claim. The first kind of evidence is scientific evidence. The second kind of evidence is what I will call, for lack of a better term, philosophical evidence. I will return to this second kind of evidence in the next presentation, where I will explain what contemporary philosophers call the kalam cosmological argument for the existence of God. The word kalam, by the way, is the Arabic word for traditional Islamic theology. In this presentation, however, I will focus on the first kind of evidence for the fact that the universe began to exist, the scientific evidence. The scientific evidence for the fact that the universe began to exist is new evidence that has only been discovered during the last couple of decades. The evidence is overwhelming, and scientists consider it one of the revolutionary discoveries of modern science. The essence of that evidence can be grasped by anyone with a good high school education in science at a high level. I'm now going to explain that evidence at such a high level. The explanation will take some time, and you may need to take notes, listen to it more than once, and maybe even go back to review some of your previous science education. If you feel that it gets too long, and you think that you're perfectly happy to accept the beginning of the universe as scientific fact, then you can skip ahead to the last 5 minutes of this presentation, where I summarize the position of modern scientists and then explain why the beginning of the universe is such compelling evidence for the existence of God. Before the discovery of scientific evidence for the beginning of the universe, most scientists believed that the universe was infinite and fixed in size, or in other words, static. This belief was not grounded in any particular evidence, except perhaps in the fact that most of the stars that are visible to the naked eye appear to be fixed and regular in their movements across the night sky, which gives the impression of permanence and being static. They held on to this belief even though it led to several paradoxes. One of these paradoxes is called Olbers' paradox, named after the German astronomer Heinrich Wilhelm Olbers, who made it popular in 1823, arguing that if the universe had always existed, and if it was infinite in size, with an infinite number of stars scattered throughout its expanse, then, as we looked up at the night sky, in any direction, our line of sight should always intercept some star, whether those stars are close or whether they are far. And the night sky should not be dark as we observe it, but the close and distant stars should appear to line up, as appears on the slide, and the night sky should not be dark as we observe it, but as bright as day. A couple of decades later, in 1862, several scientists popularized another paradox that was the opposite of Olber's paradox, called the heat-death paradox. According to this paradox, the night sky should not be bright as day, but pitch dark without any stars at all. This paradox is based on the second law of thermodynamics. A very approximate statement of this law is that heat naturally dissipates, and that the temperature of things in the universe naturally or spontaneously cools down. If that's the case, then if the universe has existed for an infinite amount of time, then there has been enough time for all of the stars that we see in the sky to have burned out. And the universe should have reached its heat death, or in more scientific terms, its ultimate thermal equilibrium. The very fact that we look up at the night sky and see any stars at all is evidence that the universe has not existed forever. Another paradox with an infinite and static universe was formulated earlier at the end of the 17th century by Isaac Newton, who revolutionized our understanding of planetary motion with his law of universal gravitation. But although his law explained the puzzling and seemingly unpredictable movement of planets across the night sky, it led him to ask a simple question. If the universe has existed forever, then there has been enough time for all of the planets and stars in the universe to mutually attract each other by their forces of gravity and collapse into a single massive object. Why is it then that when we look up at the night sky, we see a multitude of objects that are still so far apart from each other? There's also another paradox with gravity. If the universe is infinite in size, with an infinite number of stars and planets scattered evenly throughout space, then every object should be pulled in every direction by the gravitational forces of the infinite number of objects everywhere in the universe, and these forces of gravity should then cancel each other out. This paradox is the opposite of the previous one. According to this paradox, gravity should not be a force that has any effect at all. The fact that gravity does result in the motion of the planets around the sun, as Newton explained, should therefore suggest that it is not infinite in size, or that it has not existed forever. Together, Olber's paradox, the heat-death paradox, the paradox of gravitational collapse, and the paradox of gravitational cancellation should all suggest that the universe should be finite in size and that it should have a finite age. In 1929, American astronomer Edwin Hubble found evidence that proved all of these things, and for the first time in human history, proved something else. Not only was the universe not infinite in size, not only was it not infinite in age, it was also not static. The universe was not eternally fixed in size, as virtually everyone, even religious believers such as Muslims, Christians, and Jews in the pre-scientific age had believed. The fact that even religious believers have historically believed in a static universe is significant because we will see very shortly that a non-static universe is compelling evidence for the existence of God. And the fact that it has been accepted as true even by atheists indicates that the scientific evidence for it is extremely strong. The universe was expanding according to Hubble. Hubble's discovery was based on an analysis of the spectra of light that were emitted from the galaxies in the night sky. Let's review some high school physics. We have known since Newton that when we shine white light through a prism, it disperses the light into the various colors that compose it, and we see a rainbow. We know through laboratory experiments done on Earth that if we shine the same light through a clear container containing some element such as hydrogen or helium and so on, then gaps appear in the rainbow. These gaps are called spectral lines or absorption lines, and they are distinctive for every element. the absorption lines of hydrogen are different from the absorption lines of helium, which are different from the spectral or absorption lines of every other element. Since we know the spectral or absorption lines of every element, we can disperse the light that we detect from the galaxies in the night sky and figure out the elements that they are made of. Hubble did this and discovered that the distinctive spectral lines of the elements that made up the galaxies are all shifted towards the red end of the light spectrum. This is what scientists call redshift. The reason for this redshift, Hubble proposed, is that the galaxies are all moving away from us. Whenever a wave is emitted from an object that is moving away from us, its wavelength increases. With sound waves, this means that the pitch of the sound will seem lower. With light waves, this means that the color of the light will change and move towards the red end of the spectrum, the right-hand side on the slide that you see here. The wavelength of light decreases across its spectrum as the color changes gradually from blue on the left to red on the right. Hubble went on to measure the redshifts of 46 galaxies and then compared their distance from us to the magnitude of their redshift. He found that the further away the galaxy, the greater the redshift. In other words, the further away the galaxy, the faster it is moving away from us. It looked like everything was exploding away from everything else in space. It looked like the entire universe was expanding. Hubble had observed the expansion of the universe. The expansion of the universe was a revolutionary discovery for scientists. It has resolved paradoxes such as the ones that I just explained, and it has given coherence to many other scientific observations, laws, and theories. But the most revolutionary aspect of the fact that the universe is expanding is that it proves conclusively that the universe began to exist. Let me explain why. If the universe is static, if it has a fixed size, then if you turn back the clock of time, if you go back further and further into the past, the universe will retain its same fixed size at every time in the past. Although this is not evidence that the universe has existed forever, it may appear to someone who does not think carefully about the matter that the universe probably existed forever. I'll explain in the next presentation why, if you think carefully about the matter, you will easily see that it must have had a beginning. But let's put that aside for now. If, on the other hand, the universe is expanding, then if you turn back the clock of time, if you go back further and further into the past, 1 billion years ago, 3 billion years ago, 7 billion years ago, 11 billion years ago, 13 billion years ago, the universe will get smaller and smaller. The reason why this is so significant is that the universe cannot continue to get smaller and smaller without end. At some point in the finite past, it needs to vanish into nothing. If you know the expansion rate of the universe, then you can calculate the time when it vanishes into nothing. This is the time when the universe began to exist. According to current scientific estimates, that time was just under 14 billion years ago. As an aside, we can make a similar inference from the second law of thermodynamics, except that instead of turning the clock of time backwards, you turn it forwards. The second law of thermodynamics entails that heat is dissipating with the passage of time, as I explained a little while ago, and that there is a maximum limit to that dissipation, as I also explained. The state at which that maximum limit is reached is called thermal equilibrium. If the universe has existed forever, then enough time has passed for that thermal equilibrium to be reached. And as we look up at the night sky, we shouldn't see any stars at all. In fact, we shouldn't even exist to be able to look up at the night sky, because the biological functioning of our bodies cannot take place in a state of thermal equilibrium. The universe, therefore, must have had a beginning. The general principle is that any irreversible increase in the universe, such as its expansion, entails that the clock of time cannot be moved backwards indefinitely, because given enough time in the backward direction, the irreversible increase must have had a beginning. Any irreversible decrease in the universe on the other hand, such as the dissipation of heat, entails that the clock of time cannot have moved forwards indefinitely, because given enough time in the forward direction, the irreversible decrease must have an end. Each of these therefore entails that the universe cannot have existed forever. It must have had a beginning. Any irreversible natural increase or decrease entails that the universe cannot have existed forever. The expansion of the universe, however, is particularly compelling evidence for the beginning of the universe because it directly entails that the actual stuff from which the universe is composed, matter, energy, space, and time, all began sometime in the past, just under 14 billion light years ago. Although credit for the discovery of the universe's expansion belongs to Edwin Hubble, it should have been discovered about 15 years earlier by Albert Einstein when he first formulated his general theory of relativity. The most straightforward solution to the equations that describe his theory is that the universe is expanding. The prevailing view among scientists at that time, however, was that the universe was static, and in order to make his new theory conform to this prevailing view, in order to prevent his equations from showing that the universe was expanding, he introduced a cosmological constant. When Hubble showed later that the universe was in fact expanding, scientists abandoned this cosmological constant and accepted the straightforward solution of the equations that demonstrated the expansion of the universe. Because he didn't accept the revolutionary discovery that was predicted by his own equations, Einstein later described the introduction of the cosmological constant as his biggest blunder. In recent times, the cosmological constant is making a comeback, but in a different context, not to show that the universe is static, but to show that it is expanding faster and faster with time. This is an extremely revolutionary discovery, and I will return to it in a later presentation. For now, what I want to show is that the general theory of relativity is additional evidence for the expansion of the universe, which in turn is conclusive evidence for the fact that the universe began to exist. Now, if the universe is expanding, then as we turn the clock of time backwards, it gets smaller. If you remember your gas laws from high school chemistry, then you will remember that squeezing particles into a smaller volume causes their temperature to increase. When the universe was smaller, the same amount of matter and energy were squeezed into a smaller volume, and they therefore had a higher temperature. The farther back you go in time, the smaller the universe, and consequently, the higher the temperature. At the event at which the universe began to exist, which scientists call the Big Bang, all the matter and energy in the universe were squeezed into a tiny point, and the temperature of the universe was therefore extremely, extremely high. Then, as the universe expanded, this cosmic temperature fell lower and lower to its current level. This background temperature of the universe comes from a background energy in the universe that is a remnant of the Big Bang, when the universe began to exist. This is why, in the 1940s, scientist George Gamow and his students argued that if the Big Bang had in fact happened, then the energy from the Big Bang should now pervade the entire universe. The reason why this energy should pervade the entire universe is that according to the general theory of relativity, the universe does not just expand at its edges, but everywhere throughout itself. The universe is expanding by the expansion of space-time at every point in the universe, because of which every point in space is moving further and further away from every other point in space, somewhat like the expansion of the surface of a balloon as you blow it up. Gamow and his students predicted that the energy from the Big Bang should be detectable today as an all-pervasive blanket of microwaves that is not appearing to come from any particular source, no particular star, no particular galaxy anywhere in the universe. In 1965, two young employees of Bell Telephone Laboratories in New Jersey accidentally discovered this all-pervasive background microwave radiation. Scientists call this radiation the cosmic background microwave radiation, and it is widely considered as strong confirming evidence for the Big Bang. Scientists are now charting this background microwave radiation throughout the universe to get a better understanding of how the universe expanded into its present form. In addition to all of these discoveries, scientists have made discovery after discovery related to the composition, expansion, and evolution of the universe that repeatedly confirm that the universe originated at the Big Bang and has expanded ever since. It is now considered scientific fact that the universe is not infinite and not static, but that the universe is finite, that it is expanding, and that it began to exist. The most significant of these 3 points for us in this presentation is that the universe began to exist. At the beginning of this presentation, I explained that the existence of the universe is evidence for God's existence in 2 ways. The first is that it is contingent. The argument for God's existence from the contingency of the universe is called the argument from contingency. The second reason why the existence of the universe is evidence for God's existence is that the universe began to exist. And that's what I have been explaining in this presentation. The argument for God's existence from the fact that the universe began to exist is called the argument from creation. I said at the beginning of this presentation that this second argument, the argument for God's existence from the fact that the universe began to exist, is more compelling than the argument from contingency. And I promised that I would tell you at the end of this presentation why that is the case. The reason why the argument for the existence of God from the beginning of the universe is more compelling is that it puts divine action in the foreground. To understand what this means, I need you to recall what we learned in the previous presentation. In the previous presentation, I explained that belief in God coexists with science. It does not conflict with science and scientific explanations. And I illustrated that with the verse from the Quran that we have seen again and again from the second presentation in this series. In this verse, God describes the rain, the sending down of rain from the heavens, as divine action. And he also describes the sprouting forth of vegetation from the ground after the rain falls as divine action. Both are divine action, yet the rain has a role to play in bringing forth vegetation from the ground. Divine action coexists with scientific explanation. The verse also says that God is the one who changes the winds, and it's understood from the verse that God is the one who moves the clouds. Yet the verse also says that the changing of the winds has a role in swirling the clouds. I then explained the coexistence of divine action and scientific explanations with respect to the water cycle. And I showed that since God governs the universe in a scientifically coherent way, belief in God coexists with science and scientific explanations. What we need to do is we need to see any natural phenomenon from 2 perspectives. There is a foreground view and there is a background view. In the foreground view, the natural phenomenon is explained with reference to another natural phenomenon with respect to natural processes. This is the scientific explanation. In the background, since both the prior and the subsequent natural phenomena are contingent phenomena, each one is being brought about through divine action. Their contingency reveals the fact that they were made to be by a necessary being. But if the universe began to exist, then the beginning of the universe cannot be explained by reference to any other natural phenomenon, because there was nothing, there was no natural phenomenon before the beginning of the universe. The beginning of the universe was the beginning of natural phenomena. The beginning of the universe, therefore, puts divine action in the spotlight. There is only divine action. There is no scientific explanation. وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم.
لا إله إلا الله محمد رسول الله.